Metrology. Wow, you're studying weather. Again.
Please, let's go to YouTube, right? I think the capacity, so I will not be logged out. We should connect via YouTube. Who are the course reps again? Please, all course reps regarding your department, please collect your attendance. Because I overheard some people talking that people that are not in chemistry, how they can submit their attendance. So submit your attendance by your course reps. But why I'm making this co-host is who is the course rep of chemistry? Let me just make one person co-host for now. I don't want to be logged out again. We've wasted enough time. Who is the course rep?
Mom, yeah.
Is it which of them? Is it
Chidera.
Okay. So Chidera, you have to monitor this class, please.
Please, excuse me, ma. Please, how can we get to you to set the attendance?
You know, this air country
Okay.
go to say because say I'm not going to go happen. I want to only low in Bojo Mama air country. Police obey one in record. Baba on lecture.
Send it to my WhatsApp because you're not in school. Send it to my WhatsApp as a file. Okay, so good morning, class. So you're welcome to, please, let's go to YouTube, please, so that I will not be logged out of the class. So you're welcome to this section of FSC. Before I was logged out, I was trying to encourage us because I've witnessed that students are always afraid of chemistry courses, even people that are in chemistry. Some of them, you see them having this course as a carryover, even when they are in their 300 levels and everything. I know there are some people that I don't know whether they're extra year or something that's still having this course as an outstanding course. So that's why I'm here to encourage you that this course is not difficult. So take away the fear of chemistry is difficult so that you'll be able to excel in this FSC. So what I want you to make sure you do is that you follow the lectures, ask questions, and after each of the classes, I'm going to share this lecture material. You go through it. And if there's any question before the next class, prepare that question and ask your question. Make sure you read. And if you can lay your hands on past questions, I think I will ask the coordinator if there's anyone available. So you can go through it. This is a very easy course. You can always have your A. So take fear away from you and tell yourself that you can have A in this course. Okay? So that's what I want to encourage you on. So I don't want you to be afraid of the course. And when you guys will be on residential and make sure you succeed. Make sure you're in class. Make sure you do what you're told to do. At the end of every class, I might be giving you a classwork. That classwork is not compulsory. That classwork is for you to have a hands-on. Somebody saying he cannot hear me. Please let me know if you cannot hear me. I was thinking I'm loud enough. If you cannot hear me, maybe from your network. Because I have I don't know what network is doing. Can you hear me now? I think I was logged out. I was logged out again. I have to come on again. I was logged out. I don't know, so I have to change school network now. Okay, can you hear me? If you can hear me, let me hear. Yes, thank you very much. I'm sorry, I think this internet, I have to change my position, also change my network provider. I'm not using the school network. Let's know whether it will work better than MTN, which is my private network. Thank you very much. So I want most of us to join via YouTube because of the capacity of Zoom, so that I will not be logged out again. Please. So I think we were talking about motivating you, telling you that this is a doable thing. There's no big deal about FSC. So have that mindset that I can do this, and don't ever do this course without aiming at A. I don't want anybody to, after the course, you say you're having C. Does not make sense. So A is the goal. So, and I want to tell you can achieve that. So let's go to the course for today. I'm going to go slowly because some of you might not have a very good background in chemistry. This particular section is to introduce you to chemistry, to tell you some of the basics or the foundational things you're supposed to understand in chemistry. Now, when you're going to be going in your second year in 213, whatever you're going to learn here is going to help you in your 213. So don't cram, just study it. Understand the basics. Okay? Understand it. If you understand it, it will be better off for you. So don't just say, I want to read it because I want to pass. Read and study because you want to know. So when you're doing your 213, you will not struggle again. Okay? So that's the sense of this introduction or introductory chemistry or introduction to chemistry. Now, first, we are going to start with chemical bonding. Chemical bonding. Now, when you're talking about bonding, you're talking about connection. You're talking about, it can be two or more. So one cannot bond, just like it takes two to tango. So either two or more can bond. So in that case, in chemistry, we're talking about how chemicals can bond. In that case, how can atoms bond? Remember, if you're talking about water is a molecule, and this water is made up of hydrogen atom and oxygen atom. So how did they connect together to called water as a molecule? So that is all about chemical bonding. So in that bonding, there's so many things that it has to involve. Bonding is like a sort of partnership. When two people are working together, either they are working as partnership or one is the master while the other one is the slave. So there must be a sort of agreement in their working together. So that is a sort of bonding. In your house, you can be a son, you can be a daughter, you can be staying with your guardian that are not your parents. That's the kind of bonding that existed. Okay, so that whenever we're talking about that bonding, let it come to your mind that is two or more than two things coming together with sometimes. Now we are talking about chemical bonding. It means that this is in the chemical world, in the world of chemistry. How does atoms relate to form a compound or to form a molecule? So a chemical bond is a connection, or it can also be called an association. It can also be called a link between two atoms that is caused by two or more atoms donating or sharing of electrons. You can simply say it is a connection between atoms that is caused by either donating or sharing of electrons. In terms of donating is that like father and child can be donating because a father is responsible for your upkeep, they're donating. But in terms of business partnership, you guys are sharing because you might have contributed equally. So it is the equal partnership. So that kind of chemical bonding, either you're giving out or both of you are sharing. That is what happens. That is how chemical bonding occurs. It can occur either by donating of electron or by sharing of electron between two or more atoms. Remember, one cannot form a bond. Now, if you look at water and hydrogen, please, whenever you're in my class, make sure you have pen and paper. Don't listen alone, right? I'll always give you time for you to write something down. Now, if I have water and oxygen, before I go into the details, I want to give you a practical scenario. Now, hydrogen, by now you should know your atomic numbers. Hydrogen has atomic number of 1. Then oxygen has atomic number of what? 8. And in that 8, remember we are talking about I know you have been taught electronic configuration, how electrons fill an atomic shell. Now, if you look at oxygen, you realize that the first shell, which is 1s2, cannot go along in bonding. I'm going to talk about it when I'm talking about in the last class. We're going to talk about how this hybridization occurs. So in time, when we're talking about hybridization, you understand why 1s2 cannot form bonding when we are talking about oxygen. Now, you realize that in oxygen has 1s2 saturated, but in second energy level, we have 2x2 and 2p4, meaning that p orbital supposed to have 6 electrons and it's having 4 electrons, meaning that it needs 2. And that is why oxygen is written as O2 negative, meaning that it is collecting 2. Why hydrogen has only one electron? Now, because hydrogen will always, now if you're looking at whenever water is written, you realize that we will have H plus and O2 minus. And that's why we have H2O. Because when you cross multiply, that 2 minus in oxygen will come down and 1 in hydrogen will become up. So that's why we have H2O. So in that case, in this case of bonding, oxygen is meant to accept because it is deficient. Another case study you're talking about is case study of, if you're talking about bonding between sodium and chlorine, you realize that sodium chloride is written as NaCl. Why? Because why chlorine is going to need one atom, 1 electron, sodium it has 1 SS because sodium is 11, chlorine is 17. So it means that the one you're losing, I'm collecting from you, and they form a bond. So there are different ways these things happen. So we're going to look at in details what are the kind of bonding. How do I know the nature of bond when I see them, when I see a compound? So that's what we're going to look at. Okay? So let's continue. Now, there's a force that holds this atom together. For you to bond, there must be a force, just like saying in every relationship, there must be a connection. What connects us? That way, like a bond between parents and children is called what? This one is to say, this is my parents. So that's a family bonding. You realize the kind of family bonding, the bonding that exists between parents, your father and your mother is different from the one that exists between your parents and your cousin and your nieces. The closer, the stronger. So the force that holds atoms together in a chemical bonding, in a chemical compound, is called chemical bond. That bond, that force that makes two people to come together, it can be that force can be because they are my parents, so by birth. That force can also be by adoption. That force can also be by partnership, that is business bonding. So that force in chemistry is called chemical bonding. So it's the force that holds atoms together to form a compound. It's called chemical bonding. Now, this chemical bonding, we have types of chemical bonding. The major types are ionic. Ma, can you make this screen bigger? Okay, hope I can. Is it bigger now? Is it bigger now? Is it bigger now? I think it's because I'm using my phone. Okay, thank you. So now there are types of, the major types we're going to be talking about is ionic bonding, covalent bonding, and metallic bonding. Remember, we are talking about force that makes atoms to come together to form a compound. Some force might be a friendship. We are just friends. Who is this person to you? She's just a friend. So the force that connects you together is friendship bond. Okay? So it can be either be ionic, it can either be covalent, it can also be metallic bonding. So what are the types of bonding now? As we are going, I'll be asking you questions. So for you to understand, the question will help you to understand what we are talking about. So you will not see chemistry as one big thing. I will not see chemistry lecturers as one wicked people that don't want you to pass the course. Okay? So we have ionic bond, covalent, and metallic bond. They are the three types of chemical bonding. And we say that chemical bonding are the force that holds atoms together. So if you don't understand anything, just ask yourself, who is this person to me? Is my friend. So it means that what connects us together is a force called friendship. So in chemistry, what connects atoms together is a force called chemical bond. Okay, so these are the types of chemical bonding. We're going to look at them one after the other. Then the first thing we're going to talk about, ionic bonding. Now, have you seen when atoms loses an electron, they become ions, right? Now, and that ions can be either positively or negatively formed. When you are giving out, it becomes positive. When you're collecting, it becomes negative. That is why when you go to deposit money in the account, they credit you. And when you go and use ATM, they debit you. That debit is negative to you because you're collecting. While when you're giving out, it is positive because you're depositing. So electrons are transferred from one atom to another, resulting in formation of either positive or negative. Because when I am the one giving, I am a cation, I am positive. When I'm the one collecting an anion, I'm negative. Negative, that is why whenever you borrow money, you see your lender, your mind is keeping because you are negative, you are the basic. You understand? So that is it. So but when you're giving, the person that gives, even Bible said that blessed is the hand that gives than the one that takes. So when you're giving, your hand is up. That's why you're positive. And when you're collecting, your hand is down. That's why it's negative. Remember, if you come to a number hierarchy, upper ones are positive. When you go down, it's negative. Okay, let's take it that way. So when electrons are transferred from one atom to another, we call them ionic bonding. It means that there must be one giving, while there must be another one collecting in ionic bonding. So we have two types of ions. We have cations and anions. And cations are formed by electron transfer, while anions are formed by electron reception. And how can an atom or a metal become cation? Now, when you see an atom and you look at the chemical, the atomic number, and when you write the electronic configuration, and you realize that at the atom's shell, the atom has SS1 electron, just like sodium metal. Wherever you are, use your biro, write atomic number of sodium to be 11, and write 1s2, that's first energy level, 2s2, second energy level, 2p6, that's third, second energy level of p orbital. The remaining one is 3s. We have 3s1. If you're written it, say yes. Have you written the atomic number, electronic configuration of sodium metal? Good. Now, if you've written that, now at the atom's shell or at s orbital, we have only one electron. This one electron is telling us that sodium can easily give out one. Remember, when I have one, if I have 11 naira and you're coming to tell me I need 1 naira, I can easily give it out. Right? So now when sodium give out this one electron that it has, it's going to be N. Sodium is, the symbol is Na, to be Na plus. Plus meaning that it has given one. So it has one as credit somewhere, deposited one in an account. Right? Because it is one, that's why I put in only one S. But if we go to chlorine, atomic number of chlorine is 17. Can we write the electronic configuration now? Let's write it. 1s2, 2s2, 2p6, 3s2, 3p5. If you've written it, tell me here. Electronic configuration of chlorine. Good. Now, you look at that chlorine. P orbital has maximum of 6 electrons. But now, my p orbital is having 5 electrons. Means that it is going to require only one. That's why chlorine is negative. Because it needs one. Now, sodium is going to have one to give. Chlorine has one to receive. So both of them, I am giving and you're receiving. So both of them are going to form a bonding called ionic bonding. Because one is transferring and one is receiving. So that is what we're talking about. So that's how we have formed sodium chloride. You can see that sodium chloride, the positive and negative, they neutralize themselves. There's no number because it's 1, 1, 1. Then the electrostatic attraction between the positive and negative ion hold the compound together. So you can see the electrostatic attraction because of the positive and negative ion. That's what is going to make them to come together to form a bond. Remember, we said that chemical bond is that connection or the force that holds atoms together in a compound. So the atoms we are talking about is sodium and chlorine atom. What made them to form sodium chloride is a bond called ionic bond. Because sodium as a metal, when it loses one electron, it becomes a cation, sodium cation. While chlorine as a metal, as an atom, when it loses, when it gains one electron, it becomes negative ion. So they are now ionic form. And both of them, because of the electrostatic force of attraction, is going to connect them together and they will form a bond called sodium chloride. They form a compound called sodium chloride using ionic bonding. Bonding by the ions, which is sodium ion and chloride ion. So that is a kind of bonding. They do by ions. So let's look at the example. This is what we are talking about now. 281. Remember, we talked about how to write it. I want you to make sure you understand how to write electronic configuration, because you cannot avoid it, escape it in the exam. And remember, a CBT, you must answer all. So it's not that, oh, let me read the ones that I like. So you have to read everything. So now, sodium is 281. Because sodium has one more extra electron, because this stable noble gas configuration is 28. It's stable already, right? But because remember, one energy, first energy level is energy 1, second energy level is energy 2. If you look at the structure of sodium metal, you realize that by virtue of 11, first and second, it has been saturated already, so they are stable. So this one entered 3s1, which is another 11. So because of that, 28 is stable already. So sodium can always lose that one electron that is extra to form plus. And as it's losing it, it's going to give it to what? Chlorine, because chlorine needs it. You are in a school and you have extra 100 naira. And your good friend needs 100 naira to complete his own school fees, and you have extra you can use to buy sweets or anything. So because your friend have the need more than you, so you can easily let go of that 1 naira and help give your friend, so that your friend will be happy. Your friend collecting is, okay, I'm going to give you back. That's why I become negative. I'm borrowing you, I'm not dashing you. So at the end, you are 28 and your friend is also 288. Everybody is complete. Everybody has maintained their stable noble gas structure. You did your own by releasing, your friend did by accepting what you released. So that is what we call ionic bonding. Do we understand ionic bonding now? Before I continue, if you understand it, let me hear. If you don't understand, so I can recap. Okay, so I can continue. Thank you. So another ionic bonding example I'm going to give us is magnesium oxide. Now, if you look at magnesium has 2H2, meaning that unlike sodium that has 1 on s orbital, magnesium is going to have 2. Magnesium having 2, it can easily give us 2 because it's on s orbital. Oxygen, on the other hand, have 2 and 6, meaning oxygen is needing 2. So they are going to say, okay, oh, although I need this money, but I know I can easily give it out. It will not affect me. But please, make sure you're going to give me back. Oxygen said, okay, borrow me the 2 magnesium so I can be complete like you. The magnesium lends oxygen the 2. Magnesium that gave, because it was magnesium that gave, become positive, credit for magnesium. But because oxygen is the one receiving, it becomes negative for oxygen. So that is why we have magnesium oxide. But if you look at magnesium oxide, but because it's 2,2, that's why there's no number if it's neutral, because 2 plus annuls 2 negative. So we have magnesium oxide. Now, so it's also important for you to know that the more the capacity of lending, as in the more the bonding, the greater the charge, the more the attraction, the stronger the bond. Meaning that if I give you 1 naira and another person gave you 2 naira, the person that you'll be afraid of is one that 2 naira, because 1 naira is easier to pay than 2 naira. So the higher the charge, the greater the attraction. And that is why you realize that if you want to go and take a big loan, they will need collateral. And if you want to take small loan, they can even give you with just your BVN. Because the greater the charge, and the greater the charge, that's the more the loan you want to take, the more the attraction. They want to be very careful that their money is safe. So the attraction in sodium chloride is not as much as that in magnesium oxide. So I want you to understand that in ionic bonding, magnesium oxide has stronger bonding than sodium chloride, because the greater the charge, the greater the attraction. I come again. Magnesium oxide has a stronger bonding than sodium chloride, because the greater the charge, the higher the attraction, or the greater the attraction. I was seeing a question. I want to read that question. So any question on this? Any question on this? Any question on this? What I just said? If you have question, raise up your hand so I can give you. I can allow you. Okay. Okay, thank you. So we can continue. Now, we've talked about ionic bonding. In ionic bonding, you realize that the two ions, one is giving out, one is accepting. Because when you give out, it becomes positive. When you accept, it becomes negative. And both of them, the giver and the receiver, are forming bonding. Okay, let me also paint another picture of ionic bonding. If you are owing, you are the debtor and you are a creditor. So the bonding that between debtor and creditor is what we call ionic bonding. The debtor is collecting, creditor is giving. So that's ionic bonding. So if you don't understand any of that, then understand it that way. That one is giving, one is collecting. They are forming a relationship. And remember, the one that is collecting is always at the mercy of the one that is giving. Okay. The next bonding is called covalent bonding. In covalent bonding, it means sharing, partnership. We are sharing it. You bring the one you can bring, I'll bring the one I can bring. Then we have a meeting point of sharing. A typical example is chlorine molecule. When two people are having similar problem, they can easily form a bond. Realize those days, they said, two people that are HIV positive, they can marry. They can form a bond knowing their own, everybody, you cannot come and make jest of me. So we know how to manage ourselves. So in that case, remember chlorine need one electron to complete its own atomous shell to maintain that stable noble gas structure. So when two of them come, since I need one, we are twins, you need one. So we have to bond together to share. In that sharing, we have complemented ourselves, forming molecule. So the kind of bonding in which electron pairs are shared between atoms are called covalent bonding. That's what you see in oxygen molecule, in chlorine molecule, in hydrogen molecule. Because what I have one, you have one. I'm deficient. I cannot use, my own cannot be useful. Your own cannot be useful. But when we come together, what we have can become useful. So that is that. Is that understood? Remember, in ionic, one is transferring while one is receiving. While in covalent, one is sharing. Now, let me go back again. There's something now, if a compound that is formed by ionic bonding want to break, remember, they won't break the way they came. And they're not going to form equal. So in their breaking, there's something they call homogeneous and heterogeneous. Homogeneous is when something is divided into two equal parts, while heterogeneous is not equal parts. So in terms of ionic bonding, when they are breaking, they're going to form cation and anions. They're not going to form one. So in that kind of heterogeneous, we call it We call this one, the one of covalent bond, we call it homogeneous separation. Why the one of ionic, we call it heterogeneous, right? So in the next class, I'm going to bring a question that will make me explain why I came back on this. Now, okay. Remember that something they call fission. I think, let me say it now. What is fission? Fission is breaking apart, right? When things are coming together, we can say they're fusing. And when they're breaking apart, they are fission, Fi. Now, when I have a compound that is sodium, let me say sodium chloride. When they want to, this is sodium chloride is a compound that formed by fusion, right? Sodium ion and chlorine ion. They fuse together to form a compound called sodium chloride. So what of when they want to break apart? They are breaking apart, they are going to form sodium ion and chlorine ion. So in this kind of breaking apart, we call it heterolytic. Heterolytic, because they're not forming something that is similar. So in heterolytic fission, we are going to form cations and anions. And this is a result of ionic bonding. Why in covalent bonding, we are going to form homolytic fission, homo. And when they break in homolytic, they are going to form radicals. Homolytic fission is a function of radicals. That is why you talk about chlorine radical, hydrogen radical. So when they're going to break out, they're going to break out as radicals because they're similar. Oxygen can be radical. So whenever there is covalent bonding and they want to break apart, they're going to form radicals. And when we have ionic bonding, a compound breaking out, since remember, if you look at this ionic bonding, you realize that the compounds are not the same. That's why we call them hetero, because they are similar, they're not similar. If you come to covalent bond, they realize that the compounds are similar. That will call it homo. So we have heterolytic and we have homolytic. Homolytic form radicals, while heterolytic form cations and anions. Please note it. Any questions so far? Any question? Please recap. Somebody say I should recap. Now please recap what you just said, okay? I said, somebody say no question. Homolytic. Okay. When you look at a compound that is called ionic bonding, this is one thing you look at. You're going to know about ionic bonding. Heterolytic. Hetero, H-E-T-E-R-O. Hetero, H-E-T-E-R-O-L-Y-T-I-C. Then homo, H-O-M-O. Then lytic. Now, whenever you see a compound, for you to say, is this compound ionic or covalent? Ionic, there must be different atoms or different metals. You cannot have two chlorine and call it ionic. There must be different. So whenever we're talking about ionic bond, you can see that one compound must be the one that is giving, another one must be the one that is receiving. So they're not the same metals or the same atoms, they are different. Now, if you come to covalent, you realize that the things we are dealing with are similar. Two similar compounds or two similar atoms are involved. Now, whenever you see two similar atoms forming a molecule, when they want to separate, they're going to form radicals. And the process is called homolytic fission. F-I-S-S-I-O-N, homolytic fission. Then when you see that atoms that are different, that form a compound and they want to break, they're going to also break into, because they're different, they're going to break by the process called heterolytic fission, Fi. When they're coming together, we'll call it heterolytic fusion, Fu. Coming together, breaking at its fission. So because these are some of the mistakes people make when you're talking about CBT, they can ask you a similar question, but because you did not know that fission and fusion are not the same. They can give you fission, they can give you fusion. So when you know that you're talking about breaking apart, you cannot fuse, you can fuse. So when you see similar atoms forming a molecule, they are called covalent, they are similar. And when they want to break apart, they are going to form radicals. And the process is called homolytic fission. Why those ones that are not similar, one is giving out, one is accepting, yes, heterolytic. The one that is giving out is forming cation. The one that is accepting is forming anion. When they form bonding, we call it ionic bonding. And the process of forming this bond is called, you can call it heterolytic fusion. When they want to break apart to form their respective ions, we call it heterolytic fission. I hope that's clear. Can I continue? Are you okay with this? Are you okay? Okay. Okay, thank you. So the next one we're going to talk about is metallic bonding. Metallic bonding. Well, remember, bonding is sort of connection, link, or association between two atoms, two or more atoms. And I said it can only be more, it cannot be just one. It be either minimum of two. So in metallic bonding, let me expand this more so you can see. So this is a type of bonding where electrons are shared across large volume of metal atoms ion cores. This is a very unique, it's not like covalent, it's not like ionic. So it's like arrays of positive ions in a sea of electrons. Now we have positive ions, and then there are electrons that can come and form bonding in the midst of all these electrons. So these positive ions, we have electrons coming from bonding. There will be array. They're forming. So that's the kind of bonding you see when you talk about this is wire. This is the conducting of electricity. It's their kind of bonding that forms. So it's a type of bonding where electrons are shared across large volume of metal atoms ion core. So there's so many sharing. This metal is being held by a strong force of attraction. Remember, these electrons are delocalizable. They can move around. Remember that moving around, when they are able to move around, you can see the way they are moving around. When they are moving around, they can change any form. They are not at a particular place. So that's when we talk about metals are conductors of electricity because of the ability to move around, right? So that ability of moving around is how they generate electrical forces. So the kind of bonding that exists between positive ions in a sea of electrons is called metallic bonding. So simply put, metallic bonding is a type of bonding that exists in presence of positive ions in a sea of electrons. Sea of electrons means that there are so many electrons. So these electrons are delocalizable. They can move around these positive ions. When they move around, they generate charge, and we call it electric charge. That's why you see that wires conduct electricity. That's what we say conductor of electricity. That's from metallic bonding. Because they are always moving around, releasing charges in the sea of electrons. So there are so many electrons that move around these positive ions. So these electrons they are mobile. Now, we have a very volume of positive ions. There are so many positive ions. Now, and then there is electrons. These electrons, because the electrons are mobile, they can be able, you can see the first image. This first image, you can see those dot are the electrons. So these electrons are able to move around these positive ions because they are delocalizable, they can move around. The positive ions are static, they're not moving. Electrons are what is delocalizable. So when these electrons are moving around them, they are generating charges. This kind of bonding, this kind of relationship is called metallic bonding, where there are array of positive ions in sea of electrons. There are so many electrons, but there are fixed positive ions by which these electrons can delocalize themselves around. This metal is held by a strong forces of attraction between the delocalized electron and positive ions. So this is a metal that has so many positive ions in the sea of electrons. So because of there's always force of attraction, that's the kind of metal we use in electricity. Because when these electrons are moving in the area of positive ions, they are going to generate charges as they move. Oh, you have another class. I'm stopping. I want to stop here. I'm going to stop here. Okay. So we talk about types of metal. We talk about covalent, ionic, and metallic. Metallic is kind of bonding that occur when there are array of positive ions in sea of electrons. And it's very strong. The force of attraction is stronger because these electrons are always moving. When they move, they generate charges. And that is what is being used. We'll talk about this wire is shocking me because electrons are moving. They are sparking, they are generating charges. All right. So because of the challenges we have today, I think by Wednesday is going to be a better class. Okay, because some of this. So what I'm going to do is that before I share the YouTube video would have been in the class, and whenever the class gets to 290, please we start joining the YouTube direct. So don't interrupt the class, and I will not be logged out. So drop your questions. Drop your questions, but doesn't necessarily. Please, can you ask your question? Covalent is sharing of electrons. Covalent is sharing of electrons. Why ionic is transfer of electrons. Okay, so if there's any question, please ask me. If you cannot ask on the general platform, because so that it will not be mobbled up with some outstanding, you can ask me privately. Then I can also ask you. I can answer you in the general class. Okay, we'll talk about those. There are so many kinds of bonding. We are talking about the major types of bonding. We have coordinate covalent, yes. So I don't understand metallic bonding. In the next class, I think we are going to, okay, next class, we're going to continue for metallic bonding. Okay, let's continue on that in the next class because of challenges we have today. So we're going to talk about this. There are so many types of bonding. I said the three major types, that's what to talk about. In the next class, just drop your questions, what you want to know more about on the bonding before we move to others. Okay, the essence is for you to know the introductory part of chemistry. Thank you very much. See you in the next class. With the next class, we're going to talk more of metallic bonding. I can also throw light on dative bonding and coordinate covalent bonding. So thank you very much. See you in the next class on Wednesday, same time.